Hey class, I am coming with you with an example from section 2.5 in our Webassign homework. 2.5 is all about continuity, which for the most part, I feel like a lot of it is intuitive and makes sense, but some of it gets a little tricky. Okay, so for instance, number 8 says, consider the following function. F of x equals x minus 4 divided by x squared minus 16. Okay, so first things first, if this was a previous section, we would maybe first just start out by saying, okay, like, even though if we were to try to find the limit as x approaches 4 for this function, right? The limit as x approaches 4 of x minus 4 divided by x squared minus 16, right? If this was a previous section, we'd be like, oop, okay, I can't plug in 4, can't use direct substitution the way it is right now, but I could use some algebra to rewrite this. And I could leave x minus 4 in the numerator, and I could rewrite the denominator in factored form, and then I could cancel out x minus 4, right? Just want to make sure we're on the same page. This was like kind of from something that maybe you've probably seen before in like a rational functions unit, just without this limit notation maybe on it. So if we cancel out the x minus 4s, then we could then substitute in 4, and we could get 1 over 8 would be the limit. However, there's still a hole there. Okay, so just kind of bringing back to all of our previous classes, this would technically be there's a hole at 1 over 8, and there's like an asymptote at x equals negative 4 if we really had to, right? That was, again, previously. But then it says, explain why f has a removable discontinuity x equals 4. And they want us to use like the continuity rules, right? So let's talk about this. First of all, there's 3 like conditions of continuity. One says that, let's say we're talking about like if something is continuous at x equals a, and sometimes these are in like different order. So sorry if this isn't the exact same order as a textbook, but one thing is that like f of a is defined. Okay, so I can plug in, no matter, without any sort of trickery, I can plug in 4 here, and I would be able to just do that, right? I could do that. I could plug in 4 and get an output, but no, okay, can't do that for this problem. But just to make sure, in general, if f of a is defined, and also the limit as x approaches a of f of x exists. Okay, now for this problem, this limit did exist, right? I could find this limit, but it technically failed like the first condition. And the last condition to say that something is continuous is to say that the limit has to equal actually the function at that point, right? So we also don't have that because we didn't even get past, we weren't able to just plug in 4 and get an output. Okay, so those are like the 3 conditions of continuity, but then beyond that, there's also something else. There's either a removable discontinuity, or you could think of something as an infinite discontinuity, right? So like a removable discontinuity is really what we would think of before now as a whole. Okay, so from, again, this what we could do, how we factored this and canceled it out, and then we're able to then like evaluate this at 4, that would be what we call a hole before. So we now know this is a removable discontinuity, right? If we were not able to then plug in 4, then that would be the equivalent of like an asymptote, right? An asymptote is like an infinite discontinuity, right? Because it's either going up to infinity or to negative infinity, one or the other, or both. If approaching from the left is going up and the approaching from the right is going down. Okay, so all that leads me to this problem. It says, explain why f has a removable discontinuity. So one thing that we can see is that, like, okay, f of 4 is undefined because I can't plug in 4 originally, right? I can't just plug in 4 and call it a day. I would have dividing by 0, which I can't be having. So it's definitely undefined. Then it says f of 4 and the limit of f as x approaches 4 of f of x are finite, but they're not equal. Well, it's not that one because once again, f of 4 is not defined, right? So we don't have an f of 4, so they're definitely not equal, right? So that's like sort of the second condition of continuity, but we can't get to the second condition if the first condition isn't there, right? So it's definitely not, we're not going to select that f of 4 and the limit of x approaches 4 are finite but not equal. No, because f of 4 doesn't even exist. Then it says the limit as x approaches f of x does not exist. That's not true either. Okay, the limit does exist. It's 1 over 8. So that's not it. However, I think the next checkbox where it says the limit as x approaches 4 of f of x is finite, that is true. We were able to do some algebra to be able to actually substitute in 4 after we were able to cancel out x minus 4. So that is finite. It does exist. I just had to do some trickery to get there. Okay, and none of the above doesn't apply because I already selected those first two. Okay, and then it says redefine f of 4 so that is continuous at x equals 4, and thus the discontinuity is removed. So you'll sometimes see this. This is like pretty much saying, like make it a piecewise function. Okay, so for instance, let's say instead we had this function. Let's say the function follows this rule of x minus 4 divided by x squared minus 16 most places. However, specifically at x equals 4, we're gonna like fill in the hole. Okay, we're gonna like make this function equal whatever the y value was if that hole wasn't plucked out. And how do we know what that is? That's just whatever the limit actually was. Okay, so they're essentially saying like make this so it is continuous, and then go from there. Okay, so I would say, okay, for everywhere, again, they're just like hypothetical, really. For everywhere except for 4, it's gonna follow the function x minus 4 divided by x squared minus 16. But at x equals 4, which is where it's discontinuous, I'm gonna just say the y value is 1/8. So it's just sort of filling in the hole that we would have had there at 4 1/8. Okay, so I hope that makes sense. Again, that was number 8 from the 2.5 WebAssign, but keep me posted on how things are going. 2.6 is a little challenging, not gonna lie, because there's a lot of like infinity talk. And infinity talk is confusing. It's challenging to think about infinity all the time. It also relies a lot on our knowledge of graphs, which can sometimes be great, sometimes not. So let me know how that's going when you get to it. Okay, thank you, class.